Okay guys, so let's continue on seeing some more questions on the heating effect on carbonates and bicarbonates, which we discussed in the previous lectures. Okay, so let's say we have a 10 gram of a sample of MgCO3. Okay, and there is a mixture in which we have MgCO3 and Na2CO3, and this mixture was heated and the CO2 gas liberated was collected in 1 atm and 300 Kelvin temperature pressure. Okay, and which occupied 2.463 liter volume. Okay, so CO2 gas liberated was collected at pressure equals to 1 atm and temperature equals to 300 Kelvin. Okay, and the volume occupied by the gas was 2.463 liter. Okay, so we have to calculate the weight percentage of MgCO3 in the sample and weight of residue. Okay, so the reaction will go forward as MgCO3 is heated to get MgO plus CO2, and as we know that Na2CO3 will not decompose as we have discussed in the previous lecture. Hence only CO2 will be liberated from MgCO3. Okay, and considering CO2 as idle gas, as it is not explicitly mentioned anything, so we'll be considering idle gas. So N would be PV upon RT, so that would give us 0.1. You can just put in the values of P as 1, volume as 2.463, R as 0.082 and T as 300, so that will give 0.1 mole of CO2. Okay, so as the number of moles of CO2 produced would be the number of moles of CO3 or MgCO3 consumed, hence number of moles of MgCO3 consumed would be 0.1. Okay, so mass of MgCO3 in the sample would be, this implies mass of MgCO3 in the sample would be 0.1 into 84, that would give us 8.4 grams. Okay, so the mass percentage of MgCO3 would be mass of MgCO3 over total mass. Okay, so the mass of MgCO into 100. So mass of MgCO3 produced in the mixture was, or rather mass of MgCO3 consumed in the reaction was 8.4. Total mass of the mixture which contains MgCO3 plus Na2CO3 was 10 grams. Okay, so this will give the mass percentage of MgCO3 as 84%. Okay, and let's calculate the mass of residue also. So mass of residue would be what all compounds would be remaining. So that would be mass of MgO plus mass of Na2CO3 would be the residue in the mixture. Okay, so what is the mass of MgO that would be produced? 0.1 moles of CO2 were produced, so 0.1 moles of MgO would also be produced. Multiply it with, we can have, what is the mass of MgO? So mass of MgO would be 44 grams. Okay, oh sorry, mass of Mg is 24 plus 16, which gives 40. Okay, so this is not 44, this is 40. Plus mass of Na2CO3 would be 10 minus 8.4, because 8.4 is the mass of MgCO3. Okay, so this would be 4 plus 1.6, or 5.6 grams of residue would be formed after the reaction. Let's go into another question. Here we have a mixture of NaI plus NaCl. This is the mixture. Okay, when reacted with excess H2SO4, this produce the same weight of sodium sulfate as that of original mixture. Okay, so we have to calculate percentage of NaI in the mixture. Okay, so this produced same weight of Na2SO4 as that of the original mixture. Okay, so let's write the two reactions. When NaI reacts with H2SO4, the reaction would proceed forward as Na2SO4 plus Hi. So after balancing the equation, we'll get 2 and 2 here. This is the first reaction that will take place in the mixture, and the second reaction that will take place is NaCl plus again H2SO4 would produce Na2SO4 plus 2 moles of HCl. Again balancing, we'll get this equation. Okay, so now let us assume that let the mixture's mass would be 100 grams. Okay, let's take weight of NaI to be x grams and weight of NaCl to be 100 minus x. Okay, now we have been given that obviously molar mass of, you can calculate NaI would be 23 plus 127, that will give us 150. Okay, and molar mass of NaCl would be 58.5. obviously these are in gram per mole. Okay, now according to the first reaction, that says that we have 2 moles of NaI on reacting with H2SO4 produced Na2SO4 plus 2 moles of Na or other Hi. Okay, so we have x moles, so total moles would be x grams divided by molar mass of NaI, which is 150 gram per mole. Okay, so what would be the mole of Na2SO4 that would be produced? Mole would be half of moles of NaI, that would be x by 300, and this produced would be again x by 150. Okay, and according to the second reaction, we would have that when I done the reaction again, NaCl plus H2SO4 produces Na2SO4 plus 2 moles of HCl. Okay, so 2 moles of NaCl would be 100 minus, the moles would be 100 minus x divided by 58.5. okay, and what moles of Na2SO4 would be produced? It would be 100 minus x over 117, and HCl produced would be 100 minus x over 58.5. okay, so therefore total moles of H2SO4 produced would be producing the first reaction plus producing the second reaction, that would be x by 300 plus 100 minus x by 117. okay, now what would be the weight of H2SO4 produced? That would be total number of moles multiplied by weight of Na2SO4, that is, oh, this is not H2SO4, this is Na2SO4. This is Na2SO4. And where are these two terms coming from? This one and this one. So x upon 300 plus 100 minus x upon 117 into what is the molar weight, molar mass of Na2SO4, it is 142 gram per mole. So this is the number of moles and this is the molar mass that will give us the weight of Na2SO4. Why? Because number of moles equals to given mass upon molar mass. So mass would be number of moles into molar mass, number of moles into molar mass. This is the given mass, or rather mass that would be produced, and this mass, which is equal to 100, or the mass of the mixture of NaI plus NaCl. Okay, so just equate this to 100 into 142, equate this to 100 and get the value of x. Simple mathematical high school algebra problem. So just calculate the weight of x, which is weight of NaI, which is 20, that should come out to be 28.86 grams. So you can just solve this equation and verify your answer here. Okay, so this brings us to the end of this lecture. In the next lecture we'll be discussing some more interesting problems. Okay, so till then, good luck and goodbye.